Now question 2 is asking to list. So we've got part A and part B. Part A says list the types of electromagnetic radiation in descending order with respect to energy and frequency. List the types of electromagnetic radiation in descending order with respect to energy and frequency. So I need to mention to say the formula that is going to be very useful under the study of atomic structure. One of them is this one, which is of course Planck's. Okay, and then the other thing that you should know by now is that the V that is in this formula is representing frequency, and then frequency is inversely proportional to the wavelength, which means that if the frequency is higher, it means the wavelength is lower. Okay, so this very formula can be combined using a constant of speed of light. So if we're to substitute in the Planck's formula, they are going to have, where there's a frequency, we can also put speed of light over wavelength. So this is another form of equation that you can use. Okay, so when they say list the types of electromagnetic radiation in descending order with respect to energy and frequency, so we're focusing on the ones with high frequency. Okay, and then we descend. We arrange them in descending order from the highest to the lowest. Okay, so in other terms, that means the wavelength is going to be in ascending order. Okay, so we're trying to arrange them in descending order in respect to energy, and then you've seen that from our formula, energy is directly proportional to the frequency, right? So this is the frequency, and then on the other end, we've seen that energy is inversely proportional to the wavelength. Okay, so therefore the highest in terms of frequency and energy that you need to know is we've got the gamma, sometimes called the Y rays, and then we've got the X rays, we've got the UV, that's ultraviolet, and then we have visible light, and then we have infrared, and then we have the microwaves, and then finally the radio waves. Of course, under the radio waves, that's where you have the short, the medium, and the long waves. Okay, so now some of you are wondering, how can I easily remember this? So you can actually, one way you can easily remember, let me write for you something that can help you. So gamma rays has got the highest frequency, okay, and then radio waves has got the lowest frequency. Okay, so great X anchor usually visits, okay, so already we have the G, we have the X, we have the U, we have the V, and then usually visits in, and then we're remaining with just 2. So for the M, we can use March and then until retirement. Okay, so great X anchor usually visits in March, until retirement. Okay, so until is just helping us finish come up with a complete sentence. So if you can remember this, you're good. So great X anchor usually visits in March until retirement. Okay, if you can remember this, you'll be able to remember the order from the highest frequency. You know G is for gamma, X for X-rays, Okay, or I can remove usually, so that we can just say great ex uncle visits in March until retirement. So the U for the uncle can represent UV, and then V for visible light, and then infrared there, and then we've got M for micro, and then R for radio waves. Okay, so that's it for question A. Okay, so we are now on B. So we are given representative wavelengths in the infrared, ultraviolet, and X-ray regions of the electromagnetic spectrum. And then what are we asked now? So we are taught to determine the energy of a photon of each radiation. Okay, so which has the greatest amount of energy per photon, and which one has the least? So what do we do? So one thing that we know is we already know that in comparison from what we know, great ex uncle visits in March until retirement. So from there we know that obviously the one that is expected to have higher energy is the X-ray, and then the least should be infrared in this order. Okay, now we've been given the wavelength, so the formula that we're going to be using is this formula. So since we've been given the wavelength, we know that the formula is going to change to C over the wavelength. Since we know the energy and the wavelength are inversely proportional, and then we use a constant speed of light. The other formula that is useful that you can remember is frequency is speed of light over wavelength. These are inversely proportional. So the formula we have is C, that is, let me start with Planck's constant, hc over the wavelength. Okay, so we'll be substituting. So our Planck's constant is 6.626 times 10 to the power negative 84. The units are joule second. You know the units of frequency, we're going to be second negative, that's a hertz. Okay, so multiply by the speed of light, which is approximately 3.0 times 10 to the power 8, and then of course divided by the wavelength. So to save on space, what I'll be doing is, we know that formula already, so we have infrared there, we'll write the answer there, and then we have the UV, and then we have the X-ray. So we'll just be plugging in the value of the wavelength. So beginning with the very first one, 1.0 times 10 to the power negative 6. That is for infrared. So grab your calculator. So 6.626 times 10 to the power negative 84, and then multiply by, so multiply by 3 times 10 to the power 8. Okay, and then after that we multiply that, or we divide that now by 1 times 10 to the power negative 6. So 3 times 10 to the power 8, and then divided by 1 times 10 to the power negative 6. Okay, so the value I'm getting is 1.9878 times 10 to the power negative 31 joules. So we can now plug in the power negative 8. So 6.626 times 10 to the power negative 84 multiplied by 3 times 10 to the power 8 divided by 1 times 10 to the power negative 8. So 1.9878 times 10 to the power negative 17. Okay, assuming I've done all my calculations okay there, and then finally 6.626 times 10 to the power negative 34 multiplied by 3 times 10 to the power 8, and then divided by 1 times 10 to the power negative. So that would be to be power negative 10. Okay. So that is 1.9878 times 10 to the power negative 15. So for the very first one, it was an issue for calculations. Okay. So if you check, there's a difference of between 7 and 5. That's a difference of 2. So obviously we expect this to have a different power there, which should be also the difference of 2, which should be negative 910. So let me just redo that. 6.626 times 10 to the power negative 34 multiplied by 3 times 10 to the power 8 divided by 1 times 10 to the power negative 6. Yes, so that is the order. So of course all these should have units, joules, because we are calculating the energy. So which one has got the greatest energy here? So just like we predicted, so X has got the highest, and then of course, so one thing that we are seeing is the one that had the greater, a longer wavelength has got lower energy, the lowest actually. So the one which has got the least is infrared in this case. Okay.